Now, what I think we might do is we might just jump to October 5/1/2020, which is towards the back of the sheet. Oh, yeah, up the front. Okay, so here we have the time in minutes that Carly spends each day on social media, normally distributed with the mean is 125. So mean is 125. The standard deviation is 24. And on how many days of a 365 day year would you expect him to spend more, so more than 142 minutes on social media? So the first thing that we want to do is standardize the data here. So we're going to go Z equals, and remember we put our X value in here, so 142. We subtract the mean, and then we divide by the standard deviation. So in this case, that's 24, and we should get a Z value for that. What is it there, Preston? 0. And then is it 3 recurring after that? Yeah, cool. Okay, fine. Now we're wanting to find out when it's more than this. So we're trying to find the probability that Z is greater than 0.7083 recurring. And so it's a situation like this on our normal distribution curve. Here's our mean. And this is, say, 0.7083. And we're kind of wanting this bit here, eh? So that is going to be equal to, does anyone know? Yes? Now, if we look this up on our table, so 7083, so 7, 0 here, 7, 0, and then 8. What's 8? Is it 24? So 7, is it, what is it, 7604? Yeah, okay, so 7604. We're adding this 24 here to this, so it should be 0.0024 plus that. And so the answer is going to be 1 minus 0.7604, which gives us 0.2396. Okay, now this is the probability that he will spend more than 142 minutes on social media, but the question is asking us how many days of the year. So that's the probability just for one day, isn't it? So we want to therefore go 365 multiplied by this 0.2396, and this should give us the number of days that he is spending more than that time on social media. So that's a total of 87 days, I think. So that's 5 marks there. I think it's a nice question. I think it's quite good. Now, this one actually is not normal distribution. This is a bit different, isn't it? See if you can tell what we've got here. Find the probability that Kylie spends more than 142 minutes on social media on fewer than 2 of 10 randomly chosen days. So what is this? This is not normal distribution. I think so, no. Binomial? Why is it binomial? There's a probability of success, is that one. And then the probability of failure is, I guess, that other one that we had up here, which was, what was that, 7604. There's two options, they're independent of each other, and we're looking at discrete, so 2 out of 10 days, fewer than 2 out of 10 days. So we're going to go, well, what is the chance of it, him spending more than 142 minutes on 0 days? So that would be 10, choose 0. And then the success will be 2396 to the 0, because he's not doing it any of the days, and therefore he's failing to spend more time, more than 142 minutes on all of the other days, so that would be to the 10. And then next, what if he spends more than 142 minutes on one day? So that would be 10, choose 1. This time the success will be on one day, so it's to the power of 1. And then all of the other days, that would be 9 days that he fails to do that. Now, fewer than 2. So I think that's it, isn't it? Because we're not going to count the 2. So we just chuck this into the calculator to get our result. Anyone want to shout out an answer when they've got it? Yep, that's good. Yep. They often give you marks for doing, I've noticed, like the steps. So I'll say that again, 0.065. Do a few more. 4, 6, 2, 8. Yeah. Okay. And then the next one. Who's got the next one? Canuck. Have I got the right? 0.203641. And then we just add them together, and we're going to round to 3 significant figures. So it should be 268, I think. 0.268, and that's our answer to 3SF. Okay. Now, here we go. On 90% of the days, Carly spends more than T minutes on social media. Calculate the value of T. Now, when you read the word 90% and you're doing normal distribution, you should think that's one of my critical values. So we go down to your critical values. 90% is Z equals 1.282. But it's 90% Carly spends more than T minutes. So if you were to sketch this, here's our, oh, that's terrible, but you get the idea. Here's mu, the mean, and if 90% is more than T, so T must be here, and 90% is more than it, which means that T must be negative 1.28. Is that what it is? Negative, is that the critical value? Negative 1.282. Okay, because 90% is 1.282, so we're at the 10%, so it must be negative 1.282. Is that making sense? Did you understand why I'm making it a negative value here, or are we confused about that? Are you confused? Okay. Okay. The 90% value of 1.282 is here. And what it means, 90% critical value means that 90% is underneath that. Okay, now since we have a line of symmetry on the standard normal distribution curve at mu, or the mean, if you want something that has 90% more than it, it's going to be over here, because there's 10% less, and over here there's 10% more. So this is 1.282, mu is 0, so this must be negative 1.282. It's on the other side. So that's why we're giving it that value. Now we can plug that into our formula. Remember, our formula is Z equals X minus mu over sigma, where mu is the mean and sigma is the standard deviation. So Z is minus 1.282 in this case. T is X, that's the value we don't know. We know the mean. What was the mean? 125, okay. And the standard deviation was 24, wasn't it? So we're just going to rearrange this formula to find out what T is. So multiply by 24, multiply the Z value by 24, and then add 125 to get T. And I'm getting T is 94.2 days. Minutes. Oh, no, wait, days, sorry. Yeah, days. Oh, 10 minutes, minutes. Yeah, wow. Hang on. Wake up. I'm glad some of you are more awake than I am here. Minutes. T minutes. Okay, there we go. Now, moving on, we've got October 52, 2021. So, still in the same series, just a different zone, this exam. Okay. The time taken in minutes to complete a particular task by employees at a large company are normally distributed. We've got mean is 32.2 and standard deviation is 9.6. And we want to find the probability that a randomly chosen employee takes more than 28.6 minutes to complete the task. So we're going to standardize the data. So Z equals 28.6 minus the mean, which is 32.2, over the standard deviation, which is 9.6. And I'm getting, does everyone agree at negative 0.375? Cool. And now we're finding the probability that someone takes more than this. So if we could sketch this on here, if the Z value is negative point, so this is mu here. If the Z value is negative 0.375, that's it there. That bit there. And we want to find the probability that they take more than that. So that's this bit here. But we don't have negative Z values on our Z table. But we know that the probability that Z is greater than negative 0.375 is equal to. Who thinks they can put it, can say what it's going to be equal to? Kenny? By 0.375. Okay, because 0.375 is, say, over here, right? And everything underneath that is equal to that blue bit there. Now we're going to read that off the table here, 375. So 3, here's 3, 7 is here, sorry, there. And then we've got to add this to it here. So we're adding 19. So, but we're adding it to the last two decimals there. So it's like add 20 to make it 63, take away 1. So 62. So 6462, I think it should be. So 6462. And that should be, that's the right answer. So that's the 3 marks there that we've got. Happy with that? Yeah. Yeah. I'm imagining so. I've just written it to, yeah, I imagine it would have been written to 3 significant figures in the exam. Mark scheme, I don't know, but I've written down 4 here. Should be 3. Okay. 20% of employees take longer than 10 minutes to complete the task. Okay. So if we're thinking about where these people fit on our normal curve, here's the mean. 50% of people take more than the mean. So if 20% people take more than t minutes, t must be over here, and this little section here must be 20%, which means 80% is underneath that, okay? So what we're going to do is we're going to go to the Z table, and we're going to look for 80%, or 8000. So not here, we're getting closer, here we go. This one here is over 8, so we're going to take this one here, and then we need to add 5, which is over here. So that means we're looking at 0.842. Does everyone agree? 0.842. So Z equals 0.842. Now we're going to apply the formula. Z equals T, take away the mean over the standard deviation. Let's chuck in all of our results here. 0.842 equals, we don't know T, we know the mean. What was the mean? 32.2. And the standard deviation is 9.6. So when you're doing the exam, make sure you write that down, rearrange to get T equals, Preston? Cool, yeah, that's what I got as well. Perfect. Okay. This one's a little bit more tricksy. Find the probability that the time taken to complete the task by a randomly chosen employee differs from the mean by less than 15 minutes. Okay, so what is the mean? What was it? Okay, so we're just going to add 15 minutes to and take 15 minutes from that. So we're looking between the probability between, what's that, 17.2 is less than the time taken is less than, what's that, 47.2. Okay, now let's not make ourselves think too hard here. Let's get the Z value for the 47 one. So Z is equal to the 47.2, which you know, take away 32.2, which you know is 15, right? Because we've done that. And we're going to chuck that over the 9.6 to get our Z value. So Z should be 1.5625. And then, hopefully you understand this, you don't need to figure out the Z number for the other one, right? Because you'd have negative 15, so you're going to get the negative value of that. So the other Z value, so we'll call that Z1, and then Z2 will be negative 1.5625. But if you want to go on your merry way and chuck in the values and find that out for yourself, that's fine. I'm okay with that. So what we're dealing with is a situation where we are trying, here's our mean, and we're looking at 15 minutes either side. So we're trying to find this bit here, okay? So who thinks they can figure out how we can do this? We could go phi 1.56. I think that's all the numbers we've got, isn't it? 1.56. Oh, we can go to 2.3. 563. We'll round it to that. Okay. And then, so what will that give us? That will give us all this green stuff. Okay. That will give us that. So that's what that bit is. But I don't want all that green stuff. So I've got to get rid of, you see I've got some excess green stuff here. That bit there. How do I get rid of that? What is that represented by? Yep. Yeah, so I'm going to take away 1 minus phi 1.563, which is, let's see, Here's another one, that grey bit there. So we're going to look this up on the table. 1.563. 1.56 and then 3 plus 4. So is it 0.941? 0.941. 0.941 take away, bracket 1 minus 0.941. 0.882. Is everyone kind of happy with the logic of how we got that middle piece in there? It's okay. Cool. All right. Now, this is the exam that last year's students had to sit, this particular one. Right. Raj wants to improve his fitness. Good on him. And so he's going for a run every day. The time and minutes of his runs have a normal distribution with a mean of 41.2 and a standard deviation of 3.6. Find the probability that on a randomly chosen day, he runs for more than 43.2 minutes. Step 1, standardize your data. Z equals, give me the formula. What are we going to do, Rihanna? Very good. I got 0.5 recurring, is that correct? Okay, 0.5 recurring. And we want the probability that it's more than that. So the probability that Z is greater than 0. And I guess we're going to go to 0.556. I guess we'll round it like that. Now, if we think about this on our curve, here's our standard normal distribution curve. Here's our mean. I want this shaded part here. So that's going to equal 1 minus phi 0.556. So I've got to write this stuff down. I can't just go straight to the answer. They want to see the method you're using. 0.556. Let's look that up. 0.5. So we're looking at this line, 0.5. 5. What is it? 7108. So equals 1 minus 0.7108, which is equal to 0.2892. Find an estimate for the number of days of the year in which Raj runs less than 43.2 minutes. Okay, so now actually we're looking at this probability here, the red bit, and so I think we know that that's this bit here, isn't it? That's the probability. So we just go 0.7108 and we're going to multiply that by the number of days in the year. And that should give us approximately 259 minutes. Days. Oh, wow. Thanks, Preston. Okay, next one. Oh, look, what are you thinking as soon as you see this 95% of days? You should be thinking critical values. So let's go over to critical values. Down here, 95% is 1.645. Okay, so, but he runs more than T minutes. So if 95% of the results are more than T minutes, you know that you're way down here, right? Because 95% more there. So it's going to be not 1.645, but negative 1.645 using the same logic as before. Are we getting why it's negative? Yeah, because 50% is in the middle. So if you've got 50% more than it, you're at the mean. If you say more than 50%, that means you're at a negative z value. Okay, so it runs more than 10 minutes. So we're just going to chuck this into our z formula. Minus 1.645 equals t, which we're trying to find out. Take away the mean, which was 41.2. Divide by standard deviation, which is 3.6. And we rearrange this to find out the result. And I get 35.3. Giving some nods, so that's positive. Oh well, that's it. Okay, good. So that's last year's series, same series that you'll be sitting this year. Not last year because we did mechanics the year before. Okay. Let's go to the front of this then and get into it. I think we've got time for probably maybe one or two more, and then we need to move on to Pure Maths 3. Oh, how are we feeling about this? Is this kind of making more sense now? It's starting, you getting the hang of it? Yeah, good. All right, number 5, Greenton. What? What the heck? Oh, wait. Okay, we've got some apples, we've got some weights, normally distributed. Okay, we've got to find the standard deviation. Okay, so key information here. There's our mean. 22% have a weight greater than 87 grams. So we're going to use this to help us find a Z value. So if 22% are more, that means 78% are less. So we look up 7.7800 on our table. 7800. So we're going to look here, and we need to add a 6 to that at the end because that's the last digit. So 0.772, is everyone in agreement? 772, cool. So we're going to apply this to the formula. X minus mu over standard deviation. So that means 0.772 equals the X value, which is 87. Take away 82. Divide by standard deviation. We're going to do some simple rearrangement here. So standard deviation is equal to, what's 87? 5. 5 over 0.772 and 6.48. Cool. Find the probability the weight of a randomly chosen apple of this variety differs from the mean weight by less than 4 grams. Okay, so it could be 4 grams either side. So we're going to do very much like we did in that previous question, a few questions back. So what is our mean? 82. So we're looking at the probability that 78 is less than X is less than, what did we say the mean was? 82, so 86. Is that right? Okay, let's find the Z value for 86. Z1 equals 86, take away my mean, so it's obviously going to be 4, divided by standard deviation, which I'm going to put in as 6.48. 6186. And therefore we know that Z2, is that right or not? 6176. Okay, sorry. I actually do have 76 here. I'm not sure why I put an 8 there. Why not? Just to check that you're listening. Z2, the 78 one, is therefore going to be, straight away we know, negative 0.6176. Okay, now what we're looking for is we're looking for that band. So here's mu, and we've got something here, and we've got something here, and we're wanting the band between them. So this is going to be equal to phi. Who reckons they know it? Phi, yep. Mm-hmm. Is everyone happy with why that's the case, or do we need explanation on that? Sing out if you want me to go over that a bit more slowly. Okay, let's look it up. 6176. 61. Oh, that one there. 6176. So we can round maybe that 7 to an 8, I think. 26. 9391 plus 0.026. What did you say that was, correct? 7317. Yep, I get the same. 0.7317. Take away 1 minus 0.7317. Oh wow, I did a really weird way last time I did this. Huh. What I did that's weird. So what I did last time I solved it is I found this area by just going 1 minus phi, 0.6, right? And then I doubled it and took it away from 1. Yeah, don't know why, but there you go. Okay, final answer anyway. That's probably when I was learning. 0. Is it 4634? Yeah. Okay. Let's make this one the last question. And I have an answer sheet printed off, which someone can take if they want. Just make sure that it goes back down the back so other people can use it when you need it. Okay, in Greenton, 70% of the adults own a car. Random sample of 8 adults. Find the probability the number of adults in the sample who own a car is less than 6. Now, there are a couple of ways of doing this. Nana's way, or the smart, not that Nana's not smart, but she's thorough. So we want to do it the fast way. So we know that the probability is going to add to 1 altogether, and we're going to take away the probability of 6, 7, or 8 people owning car, all 8 people owning cars. Okay, so that's going to be one takeaway. Now, what's the probability of 6 people owning a car? Well, this is binomial. I hope you can see it's binomial. So we're going to go 8 adults, choose 6 of them to own the car, times. Now, who reckons they know this next bit? Sunny, what do you reckon? Okay, how are we getting the 0.3? Anyone? Yep. Yeah, so those people represent the ones that don't have cars, right? So these, that's why we're screwing it, because there's 2 of them. And then we've got to add the next one in, so it should be 8, choose 7. And this time 7 people have the car and only 1 person doesn't. And then the last one is 8, choose 8, which is just 1 times 0.7 to the power of 8 times 0.3 to the power of 0. So in actual fact, it's just that one there, isn't it? 0.7 to the 8. Okay, chuck that into your calculator, see what you get. Got it. 0.552. I got a different answer, but I could be wrong. You got 0.552 as well? different answer again. Yep. That's what I got. I got 0.448. Some nods. Yeah, 1 minus. Oh, there we go. Yeah. So you found the probability that it had 6 or more. Yeah, okay, right, fine. All right, last question, part B. A random sample of 120 adults from Greenton is now chosen. Use an approximation to find the probability that more than 75 of them own a car. Now, if you had to use binomial here, it would be pretty tragic. 75, 76, 77, all the way up to 120. So we're using an approximation. So what I like to do is I go, well, X is binomial distribution. 120 is the number of trials. What's the probability of success? 0.7. Now we're going to change this into the normal distribution. And now normal distribution, we're going to put mean. Now, how do you get the mean from binomial? N times P. In this case, 120 times 0.7, which is 84. And then we've got to get the variance. How do we get the variance? Yep. NPQ. So we're going to times that 84 that we've got by Q, which in this case is 0.3, because Q is 1 minus P, which gives us, is it 25.2? Now be careful, because this is variance, and therefore standard deviation is the square root of 25.2. Okay, so that's really important, and a lot of people stuff that up when they're doing their standardization. Okay, now we want to find the probability that more than 75 of them own a car, and at this point you should be thinking continuity correction. Okay, so more than 75 own a car. So let's think about it here. Here's 74, here's 75, and here's 76 to say, for example. Right, now what is the boundary of 75? Well, we've got one here of 74.5, and here we've got 75.5, and we want more than 75, so we want probability that y is greater than 75.5. Is that okay? Now let's do our z values. Z equals 75.5 minus, what's the mean? Just worked it out to be 84. Yep. What's the standard deviation? Square root 25.2. And then we get our z value. So let's chuck that in. Yes, sorry, negative 1.693. Now, if we're thinking about where this is on our graph here, here's the mean. Negative 1.693 is out this way, and we want more. So we're looking for this part here. So I would say that is equal to phi 1.693, isn't it? Let's look that up. 1.693. 1.6 is down here. 1.69 is here, and we just need to add 3 to it. So 0.9548. 9548, and I guess we could round that to 3 significant figures of 0.955. That's it. So, does anyone want to take the rest of the answers, or should I just put them back now? You want to do it tonight?